Hi and welcome to my Python YouTube channel. It's awesome to have you here. If you like this video, a thumbs up would be great. And make sure to subscribe for future videos. I also have a blog at prosperocoder.com with lots of cool stuff, so feel free to check it out. Hi, today we're going to use Python to extrude along a function graph. We'll have a look at the linear function and the quadratic function. I'm using the 2.82 version of Blender. First of all, let's save our file, Ctrl S, in this folder, for example. Let's name it whatever you want. Extruding along function graphs in python.blend will be fine, although pretty long. And now let's delete the default cube. We're not going to need it. Now we need a single vertex to extrude it along the graph of a function. There is no option to add a single vertex in the menu, but we can easily work around it by creating any mesh object, selecting all its vertices in edit mode, deselecting one vertex, the one that you want to keep, and deleting all the others. So let's create a simple mesh. How about a plane? Shift-A, plane. With the plane selected, go to edit mode and deselect the vertex you want to keep. Let's say this one. The other three vertices should be selected. Now hit X on your keyboard and select vertices to delete the three selected vertices. Now there is only one vertex left. Select it. Well, it may be not very well visible, but you probably remember where it was. It's here. And move it to the 3D cursor, which is in the world center, so at location 0, 0, 0. To move the vertex, use the Shift plus S shortcut, Shift S, and select Selection to Cursor. Now the vertex is at the beginning of the coordinate system. Now go to the scripting workspace and create a new script. Now go to View, check Sidebar, and change the size of the font to something like 16, so it's better visible. Then you can get rid of the sidebar. Now, first of all, import the BPY module. Import BPY. Now, in the 3D view editor, which is in the upper left corner over here, go to Top View, so 7 on your numpad, and pan the view so that the vertex, which is at the same location as the cursor, is closer to the lower left corner of the editor. So hold Shift down and pan like that. This way you will mostly see the first quarter of the coordinate system. So here's the first quarter of the coordinate system. It's limited by the X and Y axes. This is the quarter where both the X values and the Y values increase. We are going to graph the linear function only in this quarter. So the first function we're going to have a look at is the linear function. Let's assume our linear function is very simple. f of x equals x. Or in another form, y equals x. We're only going to extrude in the xy plane. But what function do we need to extrude something in Blender? Well, in its basic form, so without most of the available keyword arguments it may have, the function has the following syntax. BPY OPS mesh extrude region move, where dx, dy, and dz are the translations, so not locations, translations, along the corresponding axes. Now, if the function is linear and has the form y equals x, then the values for x between 0 and 5 are the following. As you can see, as the x value increases by 1, so does the y value. The increment is 1 unit each time. So now we can write a loop, a for loop, and in the loop, let's extrude the vertex in each iteration along the graph of the function y equals x. I'm going to expand the range a bit and use the values between 0 and 10. Here's the code. For x in range 10, and here's our function used to extrude, and the values are: translate 1 unit along x, translate 1 unit along y, and don't translate along z. So here the value is 0. Now run the script. And here you can zoom in the 3D view editor to see it better. As you can see, the vertex has been extruded 10 times along the graph of the linear function y equals x. And now let's try out another linear function, y equals 2x minus 1. First, we need to clear the 3D view editor to get rid of all the vertices. So in the 3D view editor, select all, A, and then deselect the original vertex. Hold down Shift and click on the first original vertex because we need this. And delete the selected vertices by hitting X, delete vertices. Now, as you can see, our original vertex is still here. Another function is linear and has the form y equals 2x minus 1. So the first values are, as you can see, when the value of x equals 0, the value of y is negative 1, which is not in the first quarter. The graph of the function enters the first quarter at x equal to 0.5. Then y equals 2 times 0.5 minus 1. It equals 0. So let's move the vertex 0.5 units along the x-axis. So with the vertex selected, just hit G, X, 0.5. Enter. Now, if you zoom in and pan, you can see that the vertex is moved half a unit along the x-axis. Fine. And now let's make the first extrusion to the point 1.1, and then let's continue in a loop. So we need this code for extruding. Let's copy it. And what we want to do is first extrude to the first point, which is 1, 1. What we need is the value of 0.5 for x, because now it is 0.5, plus 0.5 will give us 1. Then 1 for y, because now y is equal to 0, and we need it to be moved here to 1, and 0 for z. And then let's continue in a loop. For x in range 10, and here the values are 1 for x, 2 for y, and 0 for z. Now, if you run this script now, you will see the vertex will be extruded along the graph of the function. You can now zoom in and you will see that it starts with here and then continues along the graph of the function y equals 2x minus 1. And now let's delete all the vertices except the first one. So select all, zoom in a bit to see it better, deselect the first one, X to delete vertices. Fine. Now let's use the quadratic function. In its most basic form, y equals x to the power of 2. The graph of this function is a parabola. This time we'll be graphing the function in the first and second quarter of the coordinate system. Let's limit ourselves to the range between x equal to -3 and x equal to 3. And let's take only integer values into consideration for now. The values are, as we'll be using the part of the graph between x equal to -3 and x equal to 3, the location of the original vertex must be changed. Move the vertex to the beginning of this range, so to the location -3, 9, 0. The easiest way to do it is by setting the x, y, and z location in the Properties panel, which you can open by hitting N on your keyboard. So, select the vertex, then press N, and set the x, y, and z values to the following values. -3 for x, 9 for y, and 0 for z. Now you can hit N to close this panel. And as you can see, our vertex is now at this point. This is the original point where the graph will start, at x equal to -3, the beginning of the range. Fine, and now the code. So we don't need this line of code over here. We're going to use a loop for x in range, now from -3 to 3. And this is how we calculate how much the y location should change. dy equals x times 2 plus 1. And now we can use it in this function. So the value for x should be 1, the value for y should be dy, and 0 for z. And now run the script. This is the parabola you get. Well, this works for a simple scenario like this. But suppose you need more points along the graph. To this end, we can use the Linspace function from the numpy module, which is included in Blender. Let's create 100 points. But first, let's remove all the vertices except the first one. So select all, deselect the first one, X to delete vertices. This is the one from which you want to extrude. Now make sure it's at x equal to -3 and y equal to 9, which it is. Also make sure to select the vertex so that the script can run. Select the vertex. Fine. And now the code. Well, first of all, we need the Linspace function, which is in the numpy module. So let's import the module with an alias, as we usually do. So import numpy as np. Now the Linspace function returns evenly spaced numbers over a specified interval. We want 100, hence the third argument will be needed here. Evenly spaced numbers between -3 and 3. Both negative and positive 3 will be included. This is how the Linspace function works by default. Now these will be the x coordinates. So x chords for x coordinates equals np Linspace and the arguments from -3 to +3, 100 evenly spaced numbers. Now, the y coordinates will be calculated as squares of the x coordinates. I'm using a list comprehension to create a list of y values. So, y chords equals list comprehension x to the power of 2 for x in x chords. Fine. We can use the enumerate function in our loop. This way the indices of the elements of the list will be available. And now our loop. For n x in enumerate x chords. Now the x and y translations should be only calculated if the index is less than 99. Otherwise, the index would be out of bounds after adding 1 to it. So, this is why we have to add this condition. If n, this is the index, is less than 99, do the following. Now, this code must be indented naturally. And the x and y translations are calculated as differences between neighboring elements. So, dx equals x chords n plus 1 minus x chords n. Now, dy equals y chords n plus 1 minus y chords n. Another function to extrude. Here, our values for dx, dy, and dz will be dx, which is calculated here, dy, which is calculated here, and 0 for dz. And now we can run the script. And here is our parabola. As you can see, the vertex has been extruded along this parabola. And this is generally how you can use this function to extrude in Blender using Python. Okay, that's it for this video. If you like it, a thumbs up would be great. Also, make sure to subscribe for future videos. If you want to leave a comment or ask a question, you're welcome to do so. Thanks for watching. Okay, that's it for this video. If you like it, a thumbs up would be great. Also, make sure to subscribe for future videos. If you want to leave a comment or ask a question, you're welcome to do so. Thanks for watching.